Hello and welcome to this video where I'm going to talk about my mid-engine Volvo with the V10 and the transaxle, how we made it stronger and how to reverse engineer some of the weak parts in the gearbox. When I used this combination in my Audi R8, I just raced it for a short time. I had a problem with the differential, and as you can see, this is the differential out of the car and it's totally broken. So what I think is one of the problems with this kind of transaxles is that this cover is a bit weak. So we should make this stronger by some reverse engineering, and so I will get some help with that. All of the power going to the rear wheels through this pinion here, and this one goes to the big crown wheel as you see here. And the thing is, when this applies power, it will go up on the top of the teeth. It will be some flex here because this whole differential and this ring gear is supported by this cover. It's bearing on this one, and if this one flexes a little bit, and I think it will do with some sticky tires and high horsepower, it will go on the teeth of these ones, and then it will make these gears break. So probably just a couple of, or the one teeth broke first, and then it got all of them here. So I think the thing to do in this case is to make this cover much stronger. You can see it's a cast one here. So next step, see if we can improve this diff cover. I'm here with Christian at Total Innovation in Örebro, and I have my diff cover here that needs to be stronger.
We are going to show you some reverse engineering, and we have this absolute arm from Hexagon, and it's a measuring arm that also have this laser scanner attached. You can have a probe in this as well, and with the probe we have an accuracy of about 20 microns, and with the laser about 50 microns. And this is actually the same model of arm that Red Bull Racing are using when they are, you can see on YouTube I think, when they're scanning some front wings and stuff like that.
Okay, yeah.
It's, Hexagon is a partner to Red Bull Racing.
Aha, cool. Formula 1 technology, or
yeah.
Even better, yeah.
So what we're going to do here is to scan this part and make a solid of it, and then we can also make a billet model that are much stronger, I think. So we're going to try this out. We're starting to scan. We can do it in a bunch of ways, but the plan is to scan from this direction, and then we're going to scan in the second operation from the top, and put those point clouds together.
It's some very important dimensions here. Of course, it's the bolt pattern to install it to the gearbox, but it's also here for the bearings inside.
And also some free-form surfaces that are a bit difficult to...
Yeah, not easy to measure this one with
the holes
or something.
The holes we can do, but we'll start scanning. And you see the lamp here. It's supposed to be in the green segment.
Oh, okay. So you're holding the correct distance.
Yeah. And also you have some, you see the rectangle here and the line here.
Okay, some kind of target
get
or...
the focus of the laser.
Oh, okay.
But it's actually very simple to use, because you can go over the part multiple times, and the dots are just stacking together on top of each other, and then you can filter them away. Basically, it's like painting. So we can see here, we're starting to get points on the computer. So often we are just scanning as much as we can and go over it several times, and then we can filter the points.
Okay. And yeah, pretty quick, and a lot of details in this one.
So we can use this for measurements as well with PCDMIs from Hexagon. But now we are using a software called Designer with the Recreate module that we can scan directly into Designer and make surface modeling on the parts.
See here, kind of points 15,000 K, 16 million, 17 million points, I guess. A big job then was for Christian to make a CAD model of the original cover and also make an improved cover. It was several iterations, sent some pictures of it and I had my inputs of it and then made it like this one. I also 3D printed this one and tested it if it would fit to the gearbox or in the car, if I could see something I did not like. No really big need of 3D printing, but I thought, why not?
So then we take this part into Autodesk Inventor and we do stress analysis of this.
The original one, and you can see where there is the most stress, the red one I think, and the deflection is at 500ths of a millimeter, so we can see where we can make it stronger. And the force, you can see it there, it's just pushing the bearing outwards. It's hard to know exactly what kind of forces is going into this diff cover, but I think most of the force is outwards. This is the modified version, or one of the modified. Was some iterations before it got to this design, and yeah, we can still see the center guard that is the weakest part here, but it's still a lot better than before. Also, this is in 70-75 aluminum, and it was assumed that the original was that as well, even though I'm pretty sure it's not. It's some casting, but just for comparison.
You see, this is the original part that we make from the mesh with some surface modeling on this Designer. Then the new part, I have made some new designs. We have the flange here is much thicker.
Yep.
And we also have made some reinforcements here. I think also the design of it looks pretty nice.
Yep.
There will be a lot of surface milling in this.
I've seen some like stress analysis. I know by design that these Ys is a really good design for make it strong. So that's why you can see like many racing rims have the spokes are like Ys as well. So that's yeah, it's a good looking design, and it makes the part strong when you have a round part. Yeah, the strange thing is the holes. If you see the hole pattern, it's pretty random. I don't know why they did it, but yeah, it's not
symmetrical.
No, not at all.
So when I started to make the reinforcements just out to each hole, we got so much material left between, I think, these two holes. You see the distance is longer here than here.
Yep.
And in the stress analysis, it actually got weaker that way. So I made this part symmetrical with the reinforcements instead.
Also, this piece here, I wanted to have a hole here, M18, that I will show here in a bit what I am thinking about this one. But this is not original, this one, and it will help to keep the deflection of the crown wheel. Okay, so now the part is designed and we are happy with the results in the computer, and you should fabricate the part.
Yeah, here we can see our spinner U1530, and we are using EdgeCam to make the CNC program for the part. And I can take away some. Here you see the stock. I have done some clamping surfaces.
Yeah, and it's a big stock, and it's really good material, 70-75.
Basically, we are going to mill the first operation, and it's mostly 3-axis milling, but we are having some holes here for the oil.
Yeah, I think small oil holes for the bearings there. Almost colliding. When I checked out there, it was tight to do these holes.
But clearance is clearance. I have the correct solid model of the tool, of the holder, so we can see that we are not colliding with the part. We are just perfect there. What I really like with edge cam, it's if you have the solids of the biases and the tool holders and everything, you can almost get full control of that you're not
going to crash. Okay, yeah. So it's going to warn you if you crash or stop or something.
Yes.
So you can see simulate and do everything here in the cam software, in the edge cam here before.
Are we going to pre-drill the holes for the oil? And we can see here that it will be no collisions.
So it's a bit of peck drilling, or and then the small holder
diameter 3 drill.
Okay.
So we can see here it will come out on this surface.
Yeah, very nice.
Yeah. To the O-ring groove.
Yeah, the O-ring grooves.
Relief for this. We are ready for operation 2. And I have made a fixture plate.
And what kind of tool holders? Is it hydraulic or?
This is actually from RegoFix, and it's called Power Grip.
You get good results with those ones?
Yes, yes, you get
nice.
a very good run out of the tool in that type of holder.
Yeah, so built with really nice equipment here.
Almost finished. I have done some finish milling
Yep.
on the part.
We discussed a little bit about if it should make it all smooth or leave some of these marks on it, like machining marks, so we can actually see them here. And we opted for this one to keep these ones looking cool. And yeah, it's looking exactly, I would say, here in the computer as the real part.
Yeah, and we can adjust the step over and make almost very nice surface.
Yeah, we could make it smooth as well if wanted, but it's more machine time and doesn't make much difference or any difference at all, I think, in strength. Here we have the machine that Christian is going to machine this piece here, and it's a spinner. And is it a 5-axis machine?
Yeah. It's a little different configuration of this.
Yeah, really different. We have one table here, and we got one table here to the right.
And this is B and C axis in the table, so it's a fully simultaneous 5-axis machine.
Okay.
We also got this 3-axis table.
Okay, yeah.
So we use this mostly for prototypes in small series, and it's you can also lift the table away and put the tailstock over here. And you can use this like an 4th axis. And with tailstock you can have a pretty large pieces.
Big like axle or something.
Yeah.
Yeah, you can do some pieces, maybe 3 axis here first, and then some.
Mostly that we use is first operation 5 axis, and then the rest operation 3 axis.
Yeah.
So I got the part finished in the same machine. 54 tool.
54 tools. Okay. And it's like HSK.
HSK 63.
63. Yeah. So it's that's really what to say, stiff, stable. They're really good, and a nice tool there.
Yeah. It's handmade from Innova tools for aluminum.
Yeah. Okay, so this is
for both roughing and finishing.
Okay, it is. Yeah, I've seen this color for aluminum, and they're working good.
Yeah, really nice surfaces. The coating on it, it's lasts really long.
And here we have the control panel for it, looking not many buttons. It's touchscreen.
Yeah, touchscreen. So it's Siemens 840D.
Okay, Siemens.
Yeah. On the first operation, I will put it in those shank vices.
Only small teeth, like
clamping in 3 millimeters.
3 millimeters. Yeah.
And this is actually the fixture for the second operation of your rear diff cover.
Yep.
And I have drilled and milled for those studs as well.
Okay.
So I just put it on the zero plate here. Like that. Rock solid.
And this is German manufacturer on this machine? Yeah. I've not seen it. It's not
that common.
Not that common in Sweden, maybe.
No,
yeah.
But pretty big company.
Yep.
Spindle for 20,000 RPM as well.
Okay, 20,000. Yeah.
Pretty good for all kinds of materials.
And here we have some tools racked up. Maybe this is the one for the oil hole, maybe?
Not that drill I used. It's an ordinary HSS drill, but it's the same tool holder.
Yeah, same tool holder. Very long and thin. And I guess when you're doing like the 5-axis work, you need to have many of these like longer tools, looking much longer than I have. But yeah, beautiful tools. So here we have one of these Regofix power grip. Okay.
Yeah. From Regofix. We have this clamping station. So now we are going to unclamp this tool. It's actually a really nice solution for so these are the collets.
Okay.
Put it in this position. And then we have to change it to clamping.
Okay. Let's see the pressure then.
Very good run out in these holders, and it's really good clamping.
Okay.
Clamping force. Yes, now we have milled part.
Yes, the final part. Looking beautiful.
Yeah, I think so too.
Yes, much nicer than the old
the cast one.
And much beefier as well. This one will be perfect.
A bit heavier, but
a bit heavier, but that's
see the small holes for the oil.
Yeah, for the oiling there. And big thick flange, and here O-ring groove. Yes. Beautiful.
This is the first prototype we make. We should test it in your car.
I will use it in the car and test it, and if it's working good, we can make more of them if people are interested.
If there will be some adjustment to the design or something like that.
Yeah,
I think it's
looks
really nice.
Looking really good. Yes, it is. And it has this. These ones are for heat shield for the drive shaft and the exhaust, and it's still there. Should be bolt on some other stronger bolts, but otherwise the dimensions of bearings and everything is just like the original part. Beautiful 7075, and this one is also now raw aluminum. I don't know if maybe in the future we should do some like a surface treatment, anodizing, or
I think that should look really nice on the part.
Yeah, great, good work, Christian. Very nice.
I hope
really happy about this, and it's also, I have to say, it's a lot of. First, when I thought about this 3D scanning, I thought maybe you can scan it and then almost put the file directly into the CNC machine, but it's a lot of steps.
It's a common mistake that people do, that they think it's just scan and then you get the solid from it.
Yeah, so it's a lot of steps between there, and you used maybe 3 different softwares, or so it is. It's a lot of knowledge and know how to do something like this. But that's one thing you are experts on here at Total Innovation here.
It's a really fun job to do like this.
Okay,
Parts like this. But as you said, the 3D scan, it's very fast to scan.
Yep.
But most of the time it's in the computer making something of the dot cloud.
Yeah, a lot of work there, but you can do everything here. So that's from
everything
idea, design, modification, and to the final part.
Yes.
So it started out with this one, and here we have the stock big chunk of aluminum and the final result. So thank you very much, Christian. Great work with this one, and I will do some testing, and I don't think it will be any modifications, but if I find something, we do modifications and
we fix it.
We fix it, and possible to make more of these. So now, when the season is over, I will take this apart and see how everything looks like right now. One thing is that this bolt here, you can see I had to cut it because it's interfered with the exhaust system there. Didn't think about that one because this one is much thicker, so that one need to be redone a little bit. Also, one thing is that the forces will be concentrated to one point of the gear here, not the whole one, so I think it will move, flex a little bit. And I have seen in some other transaxles for like sandrail cars with the high horsepower, they have one screw that goes in here, so that one helps, pushes against here. When this will flex and go out a bit on the teeth here, that bearing will push it down. So I will implement that one into this one as well. Never seen that one in an Lamborghini or Audi R8 diff or transmission before. That one is also adjustable, how much you want to have. And also here we have this screw that should help deflection of the ring gear. And this one is in lagered bronze in Sweden, some kind of bronze material called in English. So still looking good, a bit dirty, but yeah, we'll see. Open it up. Breaking the bolts loose, 12 nines. I've broken them loose beforehand. One other thing that we should improve on this one is to have some break out tabs or on both sides. Especially when doing shimming of the diff, it's good to, you have to remove it, install and remove it a couple of times, and then it's good to have something to break it, to take it apart. So now I have to put something in here. This is plastic. Better than steel, but it would be better to have some tabs to break it off. Coming. Cover is out, and you can see on this one. Now I had screwed it all the way in and then backed it out. I don't know what I've wrote on here. 0.5, maybe half a turn. I have not touched this one, and it's looking still beautiful, this one. Think. And the differential, we'll take it out as well. No oil was coming out, because I'm gonna send the differential for repair. Maybe a bit dark here, but at the first glance gearing is looking very good. Great, beautiful. And we have the pinion over here. So yeah, I think this is it for this episode. Thank you very much, Christian and Total Innovation here in Örebro, for making this great piece for my Midvo. This one will live on for the next year, when we will have more power in the engine and through this gearbox as well. Thank you for watching. Bye bye.